It's another interesting basic science class with Miss Andres. Hello, superstar. It's great to have you here. Are you ready? So, what are we going to be looking at today? Our focus for today's class is properties and sources of light. Can you repeat after me? Properties and sources of light. So what's our focus? What are we going to be looking at? Our focus of today's lesson is we'll be learning about different properties of light. Light has different properties, so we're going to be looking at each property one after the other. So we will also learn about the two ways light can be produced, and we're also going to learn that with the different examples, and we're still going to look at the different sources of light. So now the question is, what are the properties of light? What are the properties of light? Now, light travels in a straight path. That's the first property of light. It travels in a straight path. Another property is light can be reflected. And another is light can be absorbed. Another is light can be refracted. And the last is light can be diffracted. I know these words look so big to you, but by the time we break them down, you will get and understand what each property means. So let's talk about diffraction. Diffraction explains that when light travels through a small opening, it can spread out in all directions. So for example, when the clouds are blocking the sun, you get to see when sometimes the cloud gets to block the sun. Even if there is a small opening within the cloud, that small opening is enough to let enough light to light up a large area on the Earth's surface. So through that small opening on the cloud, so light is able to spread out in different directions. So that's what we know as diffraction. Now let's watch the next video for a detailed teaching on the properties of light.
How does light travel? Light travels in waves. It's like when you throw a pebble in a pond and the water makes little waves around it. These waves go off in all directions. Light waves also do this. They travel in straight lines through the air. These lines are called rays. If light travels in a straight line, what happens when it hits an object in its path? Well, light cannot bend to go around something. The light rays are either reflected, absorbed, or refracted. Let us learn these terms in detail. When light hits something and bounces off of it, we say it reflects. Reflected light is what helps us to see. We see objects only when light reflects off them. When it is dark and no light is reflecting, we cannot see anything. Some objects reflect light more than others. A shiny surface reflects a lot of light. A mirror is very shiny. That's why it reflects so much light, and we can see ourselves in it. Materials that are dull do not reflect a lot of light. They absorb, soak up, a lot of light rather than reflecting it. In case of few materials, light does not reflect off them, but travels through them. When light travels through water, glass, plastic, or any other thick substance, it slows down. Think of how you're slowed down when you walk through water. This slowing down of the light speed also makes it bend or refract. Have you ever noticed that when you put a straight straw into a glass of water, it looks like the straw is bent? That's the result of refraction. A thicker liquid like syrup bends the light even more. Imagine you have in front of you a piece of plastic wrap, a piece of wax paper, and a piece of aluminum foil. If you held them up to the light to see how much light shone through them, what do you think you would find? The light would pass directly through the plastic wrap. Light passes easily through clear objects like glass and clear plastic. We call these objects transparent. The light would somewhat shine through the wax paper, but not completely. Few objects like stained glass windows and thinly colored plastic let some light through, but not all. They are translucent. What about the aluminum foil? Light would not pass through it. We call objects that block all light opaque. Probably most of the things around you right now are opaque. The floor, your desk, your chair, even yourself. When light hits an opaque object, it is stopped in its tracks. It cannot pass. Behind the object that blocks the light, you will see a shadow.
Wow, I know you learned a lot from that video. Now we're going to be looking at sources of light. What did I say? Sources of light. Light can be produced in two ways. In how many ways? In two ways. And they are naturally and artificially. Can you say that? Naturally and artificially. Light that is created naturally means it occurs on its own through natural processes. So examples are the stars, the moon, some living organisms such as fireflies and glowworms. Now, the largest source of natural light comes from the sun. What did I say? The largest source of natural light comes from the sun. Remember, light that occur through natural processes are called natural light. Now, the other is artificial light. Now, these are lights that are produced through artificial means, meaning they are man-made light. Now, without artificial light, it will be difficult for us to get much work done after the sun goes down. You see, we can use artificial light to light up dark places such as a room with no windows, or to even look for something under the couch. So you see, artificial lights are very important to us. So some examples of sources of artificial light are our light bulbs, flashlights, torch lights, television, computer, cell phone, tablet screens, and we have some other old and more classic sources of artificial light, and they are candles, oil lamps, and wood or fuel burning fires. So these are examples of artificial light. In conclusion, we must know that the largest source of natural light comes from the sun, and the sun is a huge ball of burning gases. Now, the energy that is released from these burning gases, which is the sun, comes off as heat and light towards the earth. Also, we must know that light sources can give off heat, obviously from the sun, like I said. Light and heat are often two energy forms that go hand in hand, they work hand in hand. So where there is light, there is generally heat. So it is rare to have a source of light that does not produce some heat as well. Remember, we said energy forms can be transformed into one another. In this case, light energy would definitely be transferred to heat energy almost all the time. Light energies will be transferred to heat energy. I know you've learned a lot from today's teaching. Thank you for listening. Don't forget to attempt your quiz and do your assignments. See you in my next class. Bye.